Here is a homemade RC car and mobile application I made. When this RC car is powered on, the BLE server starts operating. The mobile application has already started to search for the target device, in this case this car. So as soon as it finds the target device, it's ready to control it immediately. As you can see, it's connected. Let me try to run it. It works well. I used ESP32 as a microcontroller, and the controller app is based on Flutter. I like Flutter very much because I usually have to create not only Android apps but also iOS apps at the same time. This can greatly shorten development time. If you watch my channel, you can find several projects for communicating with Flutter and ESP32. In this project, communication between two devices use BLE, Bluetooth LE, so you can communicate between devices very easily. I don't think there is anything that can be done as simply as BLE, which requires a mobile device to directly connect to hardware to transmit or receive data. Since this is a base version of the RC CAR project, it was created with very minimal code. If this is popular, I plan to make an upgraded version. This video first deals with the hardware things of making an RC car. I will talk about mobile controllers in the next video. The reason for doing this project is simple. My kid wants to play with RC cars. I thought it would be a good idea for him to play with me because it wouldn't be fun if he played alone. Also, I started because I thought it would be more meaningful to make everything from the RC car's body to mobile applications for controllers. Of course, I made all of them. Thinking of it now, it would have been better to just buy two RC cars. Considering the material cost of the RC car I made, it would have cost much less. The first thing to do is to build the frame of the RC car. As you know, the prices of the RC car chassis vary widely. There are many body frames that are extremely expensive. Since I'm not that expert, I found a cheap RC car kit and I'm going to base my project on it. It wasn't difficult because these days not only assembly manuals but also videos are provided. This kit includes both DC and servo motors, so there was no need to purchase them separately. Not bad for $50 RC car kit. It doesn't look very luxury, but it's not that bad. Personally, I think it would have been better if it was bigger. Also, it is a bit disappointing that there is no space behind the motor. One good thing is that the chassis is metal, so it looks very sturdy. Anyway, this completes the car body. The microcontroller used here is ESP32S3. Among them, I use Seed Studio's Shower Sense. Although this is very small, it is easy to attach a camera module too, so I think it will be very useful in future projects where camera works together. Also, because it used an external antenna, it seems to have a better communication distance than other boards that use a built-in antenna. The PCB below is simply for the jump lines. It is better to organize the wires by making connector board like this rather than connecting directly to the ESP32 board. Let me wiring. The motor driver used the well-known L298N. Power is currently connected to a 12-volt battery pack. Since the 12-battery lithium-ion battery I ordered has not yet arrived, I use a battery pack containing 8 AA batteries. The 5V output from L298N is used to power the MCU. Currently, the servo motor is supplied with power through this power line, but it seems that power will need to be supplied separately. Servo motor control seems to consume more power than expected. I think this will have to be fixed in the next version. To control the DC motor, I used ESP32 motor controller PWM. In the past, we used LEDC, but PWM for motor control was added a long time ago. Check the speed as the duty cycle changes. I used the ESP32 servo library to control the servo motor. This allowed me to control the servo motor very easily. If you need to control servo motors on ESP32, I recommend this library. The rotation angle of the servo motor may vary depending on the assembly of the RC car. So you must first find the steering angle which is the best for your RC car. In my case, I had to set it to 180 degrees to the right, 45 degrees to the left, and 135 degrees for the center. Here we are. Finally, the RC car body was completed. Fortunately, the 12-volt battery arrived on time, so I was able to put it together. Let's calculate the cost of building this body so far. First, the price of this RC car kit is $49.50. The motor drivers cost $5.55 for 2 on Amazon. There was a cheaper one on AliExpress, but delivery took a long time, so I gave up. The 12-volt 2400 mAh lithium-ion battery is $25. Xiao ESP32 S3 Sense is $14, so it cost about $93. For this price, wouldn't I be able to purchase a normal 1/16 scale RC car? I also have to count my time spent developing the controller application. In this case, the overall cost will be very high. Anyway, this is not a recommended project, but since I started, I wanted to finish well. That's all for today. I will review more code side in the next video. Thanks for watching. See you on the next project.